Welcome to CityTutor's math website. I'm excited to tell you a little bit about our math curriculum and also give you an overview of the different materials, and then you will have the opportunity to see a lesson in action. So before we get into the components, a little bit about our math curriculum. It is aligned to Common Core state standards and common curricula like Eureka and Illustrative Math. It's designed to support high-impact tutoring efforts, particularly those in DC. It's good for tutors, paraprofessionals, or anyone else supplementing core instruction in a small group setting. And finally, it's written by local educators, each with over 6 years of experience. So we're thrilled that you found our resources, and we hope that it helps you implement high-impact tutoring or other high-quality interventions in DC or in similar contexts. Now I'm going to give you a little bit of information about the different materials that make up the CityTutor math curriculum. The first material that you'll see in our CityTutor math curriculum is the tutor script. And this is scripted language that gives the tutor guidance on what to say and also what to model, what to draw, or what to write to support student understanding. Most of our scripts are anywhere from 2 to 3 pages, and they're intended to be very digestible for tutors and easy to read. In our scripts, you'll also notice that there are drawings that cue the tutor for exactly what to write and how to write it to build student understanding. You'll also see that there's font that's in blue, and that gives you an idea of possible student answers and key points that you want to make sure you hit as you're helping students answer questions and think about problems. While this script gives very specific language to help tutors know exactly what to say and exactly what to do, these scripts are never intended to be read verbatim. We just find that they're a really good resource to help tutors know what to say and what to do to make sure that they're really building strong understanding of mathematical concepts. The next material that you'll see in our CityTutor math lessons are the slides. And these can be used electronically or they can be used as printables. And each slide is aligned to the tutor script. So you'll see in the slide, there's a let's talk slide. And then you'll also see in the tutor script, there's scripted language that helps the tutor launch that slide and model on that slide. And then finally, there's the student work. So there's the paper-based worksheets that become increasingly independent along with an answer key. So after the tutor goes through the core of the lesson where they are talking about the math, inviting students to talk about the math and modeling the math, there's the student work. There's the Let's Try It worksheet, which is more of a guided practice where problems are chunked bit by bit to support students with building those skills and understandings. Then there is an independent worksheet where some of the support is pulled away and students are asked to complete work independently. And then there's also an answer key, which not only supports the tutor with checking for the correct answer, but it also supports the tutor with knowing exactly how students should model the math, which is just as important as checking for answers. So now we know what the materials are in a CityTutor math lesson. Now I'm going to voice over how a lesson goes. So I'm going to give you an overview of the flow of a CityTutor lesson and how the different parts fit together. So every CityTutor lesson opens with a warm welcome. It's an opportunity for the tutor to build those connections, build community, and also maybe tuck in a little bit of review from the previous session. So you'll open your tutoring session with structured time to build connectedness and community. This is not scripted because it should feel authentic to the tutor and authentic to the students that are being tutored. After that warm welcome, the tutor is going to frame the learning. This is an opportunity for the tutor to connect to prior and or future learning. So tutors will open the lesson by reading or having the students read the daily objective, and then there is scripted language to help the tutor explicitly connect the day's skill back to what students already know and what they already can do. So this is in the script where you will see the scripted language starts to help tutors fill that content gap of knowing exactly how this day's skill fits into the larger scope of learning. After that, tutors will see the Let's Talk slides. So this is where tutors can begin to facilitate a conversation around the big math idea of the day. So tutors launch the lesson with a scripted, open-ended discussion question that allows students to discuss related knowledge and invites them to begin to think about and explore the daily skill. So again, this is scripted for the tutors, and just like I mentioned previously, some key points and possible student answers will be scripted there in blue to help the tutor know exactly where to push students and really stamp some of those big ideas. After that, you'll see the Let's Think slides. This is the meat of the lesson where tutors really get to model the math and students get to think about some of the big math ideas. So traditionally, this is the I do portion of the lesson when the tutor leads the students through that day's idea and skill. So tutors will really take the lead here, and students will be invited to follow along with guided questions, narration, and potentially some modeling on whiteboards or paper. And this is where that script is really helpful. It tells tutors exactly what to say, exactly what to draw and model, and what connections to pull in to make sure that students are really supported in that deep mathematical thinking and learning. And then finally, you'll see the Let's Try It slides and the Let's Try It worksheets. And this is where students become more independent. This is more of the traditional we do and you do portions of the lesson, the guided practice and the independent practice. And this is where tutors will support students as they try the skill out, and tutors will slowly reduce the level of support as needed. So as tutors see students becoming increasingly independent, they will pull back their support and invite students to move on with more independence and confidence. So that is how a lesson goes. Every lesson, regardless of whether it is a lesson in 3rd grade or a lesson in 8th grade, follows this flow. So both tutors and students have a really predictable way that they run their tutoring sessions and support students with building those big math ideas. In the next portion of this video, you're going to get the chance to see a CityTutor math lesson in action. Before you watch that model lesson, I suggest that you stop and pause this video and take an opportunity to preview the materials associated with the lesson that you'll see. So this lesson is a 5th grade lesson in Unit 3, Lesson 2, and the objective is that students will make equivalent fractions with sums of fractions with like denominators. In order to access all of our lesson materials, you should visit citytutordc.org/math. Let me show you how to access these materials. So once you are at the CityTutor Math homepage, you'll scroll down to find the grade level that you're looking for. In this instance, we're looking for 5th grade math. So click into the grade you're looking for. You'll see a little blurb at the top to tell you about some of the major content that students learn in this grade level. And then within each grade level, you'll see all of the materials broken down by units. For this lesson, we're going to be working in Unit 3, add and subtract fractions. Within each unit, you'll notice a quick blurb at the top to tell you a little bit about what students are learning in this unit, how it is connected to past learning, and how it is connected to future learning. And then you'll see links to each lesson that is within this unit. You are going to watch Lesson 2, make equivalent fractions with sums of fractions with like denominators. So you can go ahead and click into that lesson, which will open up the folder for you. And then you'll see a link to the script. You can also open up the aligned PowerPoint. And then finally, I recommend that you open up the Let's Try It worksheet. And then also open up the independent work and the answer key. So like I said, go ahead and visit citytutordc.org/math, preview the materials for 5th grade Unit 3 Lesson 2. And once you've done that, come back to this video, unpause, and you'll get to see a model lesson of these materials in action. Let's get started. So today we will make equivalent fractions with sums of fractions with like denominators. So we're going to continue the work that we've been doing with fractions. And remember that equivalent fractions mean that the two fractions are, that's right, the same. And so we're going to be making equivalent fractions with sums of fractions with like denominators. Does anyone remember what sums means? Sum is the answer to an addition problem. So we're going to be using everything that we know about addition and fractions to help us find equivalent fractions. Let's get started. I want to start by thinking about different ways that we can represent numbers. So we're going to start with a super simple number like the number 5. You all have learned about the number 5 since you were probably 5 years old. So let's use number bonds to think about different ways that we can represent the number 5. So one way we can represent the number 5, I just heard someone say, is with 3 and 2. 3 and 2 more make 5. That's one way we could represent the number 5. Another way we could represent the number 5 is with 1 and 3. Those are other ways that we could represent the number 5. But now let's think about different ways we can decompose or break apart a fraction. Just like we took the number 5 and we decomposed it into 3 and 2, or we decomposed it into 1 and 3, we can also decompose or break apart fractions. Let me show you. I want to look at the fraction 6/7. Say that with me. So if we want to break apart 6/7, we want to think about the different parts that make up 6/7. Remember, we have 6 pieces out of 7 pieces total. So if we broke those 6 pieces into 2 equal parts, we could have 3/7 and another 3/7. 3/7 and 3/7 makes 6/7. Another way we could show that is with a picture. So I could draw my one hole and I could cut it into 7 equal parts. That means that I'm going to make 6 cuts, just like this. 1, 2, 3, 4, 5, 6. Now I have how many pieces of those 7 pieces? That's right, I have 6 of those 7 pieces. So if I want to take these 6 pieces and break them up in a different way, just like I did up here, I could do 3/7 and 3 more 7s, and that makes 6/7 in all. Or I could also do 1/7 and 1/7 and 1/7 and 1/7 and 1/7 and 1/7 to make 6/7. So there are lots of different ways that we can break apart or decompose fractions. Now I want to look at one more example, and nobody said this, but I want you to think about what you would say to a friend if they told you that 6/7 can be broken up into 3/3 and 3/4. Look at this. Look at what this person did and think about, why doesn't 3/3 and 3/4 make 6/7? Think about that. Turn and talk to a partner. Why doesn't that make sense? That's right, because when we are talking about 6/7, the 7 represents how many pieces there are. And we have to have like denominators when we're adding fractions. So when we're talking about breaking apart 6/7, we can't use thirds and fourths. We have to make sure that our denominators or our pieces are all 7s. So instead of 3/3 and 3/4, it would be 3/7, because 3 out of 7 pieces, and another 3/7 makes 6/7, because here we have like denominators, and so when we add them together, we get 6/7. Very good. All right, read this problem with me. It says, use a number line, words, or multiplication to find the total of the expression. So it's telling us that we can use words, we can use a number line, or we can use multiplication to find the total of the expression. So here we have 1/6 plus 1/6 plus 1/6. And it's asking us to show the total 3 different ways, using a number line, using words, or using multiplication. So let's start with a number line. We know that on our number line, we have 0 to 1 because we're working with one whole. And our number line, the whole number line, is split into how many equal parts? That's right, it's going to be split into 6 equal parts because we see the fraction here, 1/6. So let's go ahead and split this number line into 6 equal parts, which means we're going to make 5 cuts on our number line. 1, 2, 3, 4, 5. Now let's go ahead and label our number line. We have 0. Now we have 1/6, 2/6, very good, 3/6, 4/6, 5/6, and then we have 1 whole, or another way to say 1 whole if our number line is split into 6 is what? That's right, 6/6. Now we want to add 1/6 plus another 6 plus another 6. So we're going to add 1/6 plus another 6 plus another 6. And when we do that, we get 3/6. We took 3 hops up the number line, which lands us on 3/6. Now, we're not quite done yet because this also tells us to use words. This is kind of reminding me of repeated addition. Remember, just like when we do repeated addition with 2 plus 2 plus 2, we can talk about equal groups there. Well, with 1/6 plus 1/6 plus 1/6, we have 3 groups. So we could say that there are 3 groups. And just like we'd say there's 3 groups of 2 for 2 plus 2 plus 2, here we can say that there's 3 groups of 1/6 because we have 1/6 and 1/6 and 1/6. And when we make 3 groups of 1/6, we get 3/6. Now, the last way that we have to show this expression is with multiplication. But if you're thinking what I'm thinking, we know that groups of is just like multiplication. So we could say that instead of 3 groups of 1/6, we can say 3 times 1/6 equals what? That's right. 3 times 1/6 equals 3/6, because 3 times 1/6 is the same as 3 groups of 1/6, and 1/6 and 1/6 and 1/6 is 3/6. So look at this. We just showed 3 different ways to represent the total of the expression 1/6 plus 1/6 plus 1/6. We showed it on a number line, we showed it with words, and we even showed it with multiplication. So I want you to think right now, how are these 3 different ways the same? And how are they different? Maybe you're noticing similarities, or maybe you're noticing differences. Go ahead and turn and talk with a partner. How are these 3 ways, the number line, the words, and the multiplication, how are they the same and how are they different? Nice sharing. So a lot of us noticed that they all got us the same answer. So we have 3/6 and 3/6 and 3/6, but they're different representations. So one shows it by cutting up a number line. Another one shows it with our groups of language, or converting repeated addition into multiplication. And then the last one is using that multiplication sign to really show how groups of is the same as multiplication. Nice work. Let's try one more example that's just a little bit different. Are you all ready? All right, here we go. This again says use a number line, words, or multiplication to find the total of the expression. But this one looks a little bit different. Turn and talk to your partner. What do you notice about this problem that's the same as the last problem? And what do you notice that's a little bit different? Go ahead. Nice work. So some of us are noticing that unlike our last problem, we don't just have unit fractions here. We don't just have one piece out of 6. We have 4/8 and 4/8 and then another 8. Other people notice that we're still adding 3 different parts, but they're not all the same. Interesting. Let's see if we can use some similar thinking to solve this problem. Let's start with a number line, but I'm noticing something here. 4/8 plus 4/8 plus 1/8. I'm thinking it might be greater than 1 whole. So I'm going to draw a number line where I have 0 to 1 and 1 to 2, just in case we go past 1 whole. All right. Now, I'm going to look at my denominator to figure out what I'm going to partition or cut my number line into. I see 8s, so I'm going to cut 1 whole into 8 equal pieces. Here I go. And again, there. Now I have 8/8 in 1 whole and another 8/8 in my second whole. And remember, when I was cutting this into 8s, I only had to make 7 little tick marks to get 8s. Okay. Now let's go back to the problem. We want to show 4/8 plus another 4/8 plus 1/8. So let's make our hops. We have 1, 2, 3, 4. So 4/8 plus 1, 2, 3, 4, plus another 4/8. I can even label it up here, 4/8 plus 4/8. And then I just want to make one little hop, just 1/8 here. So when I added 4/8 plus 4/8 plus 1/8, there's two ways I can write this, because look, I went past one whole. I got 1 and 1/8, or I got 9/8. Two different ways to write that. We can write it as a mixed number, showing that we have 1 whole plus 1 more eighth, or we can write it as an improper fraction. If you were to describe what we just did on this number line using addition or the plus sign, how would you describe what we just did? Turn and talk to your partner. Interesting. So we made 2 hops of 4 and then 1 more hop of 1. So we made 4/8 and 4/8 and then 1 more teeny tiny hop. And what we could do there is we could show that we have 2 groups of 4/8. So if we want to use our words, we could say 2 groups of, and we have 2 groups of, that's right, 4/8. And then we're not done because we didn't just have 8/8. We could say, and 1/8 is, and remember, we can write that 2 ways. We can say that it's 9/8, or we could write it as a mixed number. We could say it's 1 whole and 1/8. There, we wrote it with words. When we looked at our number line, it helped us describe it with words. Now, finally, since we don't just have equal groups like 1/8 and 1/8 and 1/8 and 1/8 here, like we did in our previous problem, we need to write our multiplication expression just a little bit differently. We can show 2 groups of 4/8 using multiplication, and then we need to add 1/8 to that amount. We can write that using our parentheses. So 2 groups of 4/8, those are our groups, and then plus 1 more 8. And look, when I solve the parentheses first, 2 groups of 4/8 is 8/8 plus 1/8 equals 9/8, or 1 whole and 1/8. So look what we just did. We just found the total of the expression 4/8 plus 4/8 plus 1/8 using a number line, using words, and using multiplication. 3 different ways to find the total of that expression. And this problem was similar to our last one, but we had to shift our thinking and shift our strategy a little bit. Turn and share with your partner, what did we have to consider differently as we tackled this problem versus the other problem? Go ahead. That's right. For this problem, the hops on the number line weren't all the same. We had to take a 4/8 hop and then another 4/8 hop, but then we just had to take a little teeny tiny hop of just 1 space. We also didn't have equal groups. This didn't look like repeated addition the way the previous one did. And so we had to use our parentheses when we were writing multiplication to show that we had 2 groups of 4/8, but then 1 more that wasn't the same. Nice work, everybody. So now let's work on making equivalent fractions with sums of fractions with like denominators together. So just like we did here, we're going to show our thinking with number lines, with words, and with multiplication like we've been doing. We can compose fractions or we can decompose fractions, but remember that the unit or the denominator remains the same. So if we're looking at eighths, the denominator is always going to be eighths. If we're looking at fourths, the denominator is always going to be fourths. That's because the size of the pieces remain the same, just like we saw today. We're not changing sevenths into fourths or thirds. They stay the same. Don't forget that today, that if you're working with eighths, they always stay eighths. Those sizes aren't changing. All right, let's do some problems together. Thank you for visiting the CityTutor Math website. We hope you'll join us as we work to co-design a public education system to serve and empower all children.